This video is on the objective calculate the test statistic, which in this case is going to be a t-value, a t-score, for a two mean hypothesis tests for population variances assumed unequal. And when the population variances are unequal, or the population standard deviations, which is just the square roots of the variances, those are assumed unequal, we have what's called a non-pooled scenario, right? Where we're not pooling the standard deviations together to estimate the population standard deviations. So you see them in parentheses at the end of the title, non-pooled estimate of the standard deviation. And this is my second video on this objective, so hopefully you've watched the first one, because I wrote out all this stuff, right? I'll show you my paper here. Alright, let me get rid of the calculator. When you're doing a two mean hypothesis test and you have two populations with unknown standard deviations, and you're assuming that the population standard deviations are unequal, right? It's this non-pooled scenario. Well, then your test statistic was this, right? Again, I kind of went through all the parts of this. Later on, you'd be looking at the distribution of the sample 1 means minus the sample 2 means, x1 bar minus x2 bar, and that would be a student's t-distribution where the number of degrees of freedom was the smaller value, the minimum value of either n1 minus 1 or n2 minus 1. So you find both of these, and whichever one's the smaller of the two is the number of degrees of freedom for your t-distribution. And the test statistic was, the difference in your sample means minus 0. So really just the difference in your sample means, because you're going to be assuming the population means are equal in the null hypothesis. So that's why this mu1 minus mu2, I'm just saying 0. And then all this divided by the square root of s1 squared over n1 plus s2 squared over n2, right, where s1 and s2 are the standard deviations of the samples. And this here was, the standard deviation of the distribution of x1 bar minus x2 bar. So hopefully you saw the first video in which I did all this, wrote all this out. And I'm just going to go into calculating the test statistic in this particular video, just nice and quick. Alright, so again, if you'd like to see more about what they have to say, click on more instruction, look at their videos, their notes, their examples, and hopefully those help you. Okay, so here a hypothesis test is performed at the 1% significance level, so that's your alpha, to determine if the mean time of faculty contact, in hours per week with students at research universities and non-research universities are different. So you have, again, the two populations here. You have faculty and students from research universities as one population, and faculty and students from non-research universities is another population. So the hypotheses were determined and data was collected in the table below for both samples. So you have your null hypothesis, your alternative hypothesis. Again, in the null hypothesis, when you actually perform the test, we're going to be assuming the equality part. You'd assume that mu1 was equal to mu2, right? That the mean time of faculty contact hours at research facilities and non-research facilities, you'd assume that they're the same, and then later make a decision, using critical values or p-value. You'd make a decision, whether or not to reject that statement. And then the alternative hypothesis is that mu1 is greater than mu2, right? That there's more time, more faculty contact at research universities than at non-research universities, right? And then alpha is 0.01. Okay, and then here's the information about the two samples. So 29, I guess, classes sampled from research universities, and the mean contact hours per week was 9.3. Sample standard deviation for the sample 1 is 2.4. The non-research, 15 observations were taken, a sample size of 15. The average for those 15 classes of faculty contact hours was 16.8 per week, and sample standard deviation of 3.9. So for the research, this 29 is N1, 9.3 is X1 bar, 2.4 is S1. And in fact, I'll just write all this out on a piece of paper here. I'll pull up a piece of paper, and let's write this stuff down. Right, so for sample 1, right, N1, the sample size, this is for the research universities, is 29. X1 bar, right, the sample mean. Sample 1 was 9.3. S1 is 2.4. And then for sample 2, right, the sample size is 15. The sample mean, X2 bar, is 16.8. And S2, the sample standard deviation, 3.9. Alright, and I'll just jump right into our test statistic. What's the test statistic? The t-score for the difference in these sample means, right, compared to a difference of 0 that we would assume from the null hypothesis. So again, the t-score is, take x1 bar minus x2 bar. So in the numerator I have 9.3 minus 16.8, and then minus 0, but there's no need to write that. Divided by the standard deviation for the distribution of x1 bar minus x2 bar, the square root of s1 squared, so 2.4 squared, divided by n1, 29, plus, and then s2 squared, 3.9 squared, divided by n2, which is 15. And I'll approximate this. And before I get to that, I'm also going to point out the fact that the distribution of x1 bars minus x2 bars here would be a student's t-distribution with 14 degrees of freedom. Remember I said earlier it was the smaller of the 2 degrees of freedom. This for the x1 bars, that would be a t-distribution with 28 degrees of freedom. And for the x2 bars, it would be a distribution with 14, and the smaller of 28 and 14 is 14. And that's what we're going to use for the difference in the two. We're going to be more conservative and use the smaller of the two numbers. But this is only for that, this non-pooled scenario. There was also a pooled scenario that was even different than this, and hopefully you'll see those videos. I've got videos in those objectives. But yeah, but that's neither here nor there. Let's actually calculate this now. All right, so I'm gonna pull up a calculator. Let me just go to the paper and pull up a calculator. We'll enter this. All right. So in parentheses in the numerator, 9.3, the x1 bar minus 16.8, the x2 bar, divided by, and then make sure this, if you have an older one, you might have to put parentheses inside here, but make sure all of this stuff is inside the square root. So the square root of 2.4, that was s1 squared, divided by n1, divided by 29, plus, and then s2 squared, 3.9 squared, divided by n2 is 15. And notice that that is again all inside the square root there. We're getting negative 6.81. Right. So our sample means, their difference, the difference between our sample means is 6.81 standard deviations below the assumed mean from the null hypothesis. Now this was a right-tailed test, right? They had a greater than in the alternative hypothesis. So this this is definitely not going to be in the right tail. This is more in the left tail, right? So I would say here you wouldn't reject the null hypothesis, but that's neither here nor there. We're not asked to do that. We're just asked to find this test statistic. All right, so going back here, this one here, right, the negative 6.81 calculation that came up. All right, let's submit that, and that's all we're asked to find. And again, please read through your answer explanations. All right, and hopefully watching me do this one and looking at more instruction, watching my other videos help you when you're working on this on your own. And thank you very much for watching.